Welcome back, everyone. We're doing it. This is it. This is the Bluefield State University MIET 392 Underground Mining Class Project Introduction. So I want to start this by taking a step back and telling a bit of a story about how we got to where we are today with the state of particularly ground control research and coal mine ground control in the United States. It's going to be a big factor in this property, because as you'll see, we've got some features thrown in that are common in southern West Virginia, including adjacent mines, um, over and underlying mines, and that sort of thing. So with that, I want to start with kind of the history of how this all happened. And way back when I was a tiny little baby, I think it was 1986. Dr. Sid Ping and his first graduate student, who studied coal mine ground control, Dr. Daniel Sue, of course, did a lot of research, in the Morgantown area in the Pittsburgh seam longwall mines, but they also did research in southern West Virginia in multiple seam conditions, and to just give you a sort of idea of what some of those areas look like. This map here just shows a bunch of different mines stacked over top of one another. Some are adjacent to each other. We have longwalls. We have room and pillar. We have old areas that were hand loaded and longwalls over top of each other, right? So look at this area. You've got longwall panels that are at an angle. So this is a really good example of what we are mining in and around in southern West Virginia, eastern Kentucky, those areas where multiple seam mining is regularly practiced. Okay, and here we see pillar recovery. Some areas you might see split pillars. There's just a multitude of things that you can run into in a situation where you're mining in areas like this. At one time, my dad said that this was the most difficult mining conditions in the world. And, after a few years of working in it, he might be right. It's, I know the Chinese are doing some crazy things at crazy angles, and the Germans have mined to 5,000 feet under multiple seam conditions. But, at the same time, the way this is laid out, the way that we have traditionally mined in this country, where we get we mine the best first, right? It doesn't matter if it's over top of or underneath of other seams, you're mining the best first. Also, you can run into situations where over and underlying mines aren't owned by the same company, right? So you've got two different companies working in two different seams above each other. And that can make things very difficult because you're not really on the same page. And it's much better if you are, right? But those situations do occur. Yeah, I've seen it before. So, getting back to sort of the history of research in this area, like I said, Dr. Ping, it started there in about 1986 or so, or at least with graduating his first student. And that sort of set what I call the Ping dynasty of ground control in coal mining at West Virginia University. And that sort of legacy continued. There's been Chris Mark, for example, perhaps the king of ground control in the United States and possibly even the world, um, started work in this same valley, right? Was working at one of the mines down there. My office was just right across from where he started working in the mines at. But and then later, he came back down and did a lot of the research in the multiple seam longwalls that were operating, like I said, over top of each other in the Eagle seam, the two gas seam. Lots of different scenarios. Mining over top first, mining underneath first, mining across, stacking pillars, putting pillars under the gob. Lots of different scenarios that were tried back then to get a method that seemed to work the best, which we will talk about as we go on in the class. So that lineage of research extended all the way up to me and a couple of my colleagues that graduated with it a few years after me. And at that length of time, we were still, like I said, looking at, in this case, particularly multiple seam interactions with room and pillar mines, right? There were no long walls left anymore. So with that, I want to move on to another subject that we talked about, or not, didn't talk about actually. I made it as part of of the discussion post. It's about mining over a long wall panel, and the sort of the periodic weighting and the fracture zone and that sort of thing. And sort of where that came from was in this particular mine that I was working at the time. We were getting ready to mine over a 1,000-foot wide long wall panel in the Eagle Seam. And so we're, close to 200 feet above it, 180 feet or so. And when we started out over the edge, we had elevated stresses here with this, the barrier underneath us. So where all this was mined out, you get abutment loading on here, and we saw it. You can see rib conditions out of a scale of 0 to 5, some of them hitting maybe a 4, at least for this mine. And then once you get out over the gob, that stress kind of goes away for the most part, right? Because there's a de-stressing in here, particularly around the edges of the panel where it's the most extreme, right? And so you see that the rib conditions got a lot better. A lot of zeros, a lot of ones, that sort of thing. But what you see is we started seeing very large fractures in the roof. And so what was going on here is we had a very thick sandstone that was down on the coal. So those tension fractures, what they are, right, is this area was caving when the original underlying mine was, coming through. It fractured this roof. And unfortunately, I did not get to track this any further, really. I ended up leaving that position and going somewhere else. But with that said, my theory was that as they keep mining through here, that these very large fractures, like I'm saying, several feet apart, maybe 4 feet of spacing, sometimes more than that. Some of the cracks were smaller. There was also displacement noticed at the top of the coal seam. So here 1.7 feet. So there was actually evidence of the subsidence itself at the top of the coal that you could see. So obviously started getting some longer bolts, right? They were putting in a lot of 8-foot torque tensions. Also switched to some 6-foot point anchor resin assisted bolts. And yeah, so I didn't get to continue this mapping project, but like I said, my theory was that as they would advance, you would re-see these groups of fractures in the roof, and it would be based on what the periodic weighting of the original longwall was. And so that's what was happening. Even this distance up into the roof above that longwall panel, you're still in the fracture zone in this case. So that's what I wanted to point that out as we had a discussion post about it. And that's what my thought process was on this, so once you start over in this area, you're going to need to, even back in here possibly, because you're still, if you can imagine this, you're looking at plan view, you're looking at the top down. If you can imagine those flat-lying layers bending over this solid boundary, you will also get compression in the roof over in this area, so you may also need extra roof support back here too. So just keep that in mind if you're ever in this scenario, that once you're mining over subsided terrain, you don't know exactly what you're going to get. You are going to need a pattern of supplemental support, which we'll talk about, that sort of thing. Okay. So I think that's enough of sort of an introduction to, the area as a whole, and how it's sort of historically significant in the way we do, particularly ground control engineering in this country. Now, for the project itself, what gave me this idea was that a while, let's say that's 11 years ago now or so, when we were working in this area, we had driven a panel. It was our third panel off that set of mains. And we started driving it up. And what we experienced was some very significant squeezing. The right side of the panel was de-stressed and looked really good. The left side had very, large amounts of material coming off the ribs. There was floor heave. The roof stayed up good. It looked good because it was, very strong. But we were experiencing floor heave in that area. And I'll tell you, it sounded like you were in a pillar section or you were in a longwall mine. Okay, so it was very noisy, seismically speaking. You could hear the rock breaking. You could feel it too. So it was events that were large enough that you could feel it in your feet. And so I knew immediately that what was going on was not normal, and that what we were experiencing was fracturing of either a thick piece of strata, either in the roof or in the floor. In this case, it could have been in the interburden. I don't know, but what our guess was that somehow we were actually actively subsiding the area. And so with that, I did a bit of a study on this. And to show you a little bit how complicated this was, you have the two gas workings here in black. That was our panel, right? The previous panel beside it had been retreat mined. It's outlined in red, that gob area. Overlying the seam, we have the pillars in blue and the gob areas in orange. So we have, gob solid boundaries right here where we know we're going to see excessive, not necessarily excessive, but elevated abutment loadings that transfer between seams, right? Underlying this mine, we have the pillars in green. So you see a lot of this has been, room and pillar, full extraction sort of mining with gob areas in magenta. But what you see here is that there are pillars here underlying this area, and some over here as well. So if you look on the left side of the section, this is a lot what the conditions looked like there. A decent bit of rib sloughage. You see this post is broken. That's sort of what we were looking at. But it didn't, like I said, it didn't quite match up with the traditional route of modeling that we would normally do. We didn't expect this to happen. We thought things were going to be okay. They obviously were not. Here's another image of 15 inches of floor heave that was measured. You can also see how sort of just sloughed off the ribs are and how jagged they kind of are in this area. That's not a lot of floor heave, but this was measured over the course of a month, so it wasn't it was still moving. That's what I'm trying to say. It was still moving at December of 2014. So I ended up doing a lot of model analysis. Long story short, I showed that by retreat mining the adjacent panel, these underlying pillars may have seen additional movement, and that there was also additional pillars in this area that had stability factors that were so low, safety factors that were so low that they had most likely failed. And instead, what we were looking at, it looked something like this, right? Instead of what we had before. And that because there was additional, pillar failure in this area, it is reasonable to assume that, there could have been additional displacement as well, and that's what we were encountering in this situation. So, long story short, we did have to abandon this panel. We sealed it off. And so with that, this is where I got the idea for the project. But I also didn't want to make it, as complicated as this. This is, you know, this is a land model analysis, numerical modeling. I want to take it back a step, um, but this is where the idea came from. So let's go back to the project map, and we'll go over that a little bit, and then I will get a presentation put together or a document with sort of all the other input parameters that you're going to need to know, right? So here's what we have. We have a mine that exists. There's they're advancing the north mains here to the north. That's why they're called the north mains. We have one east and two east mains here, and mining has finished up off the two east mains. And for that minor section, the company wants to bring it straight across and start mining one west. Okay. However, like I said, there are a few things going on. So let's open up our layers tab here. And the first thing I want to put in is some adjacent workings. Okay. So there is a mine to the left, and it's in a strange shape, and that's okay. I primarily did this because this is the area I want you to focus on. I want you to focus on laying out panels in this area, and also, taking into account that we have to stay 200 feet off of this adjacent mine. So it's limited. Our border, our boundary, our geometry, and I also have some overburden contours. And you'll see in this area, the deepest it gets is about just over 1,000 feet. Maybe right in the middle might be 1,050 or so. But it doesn't quite get to 1,100. So that's what we're looking at in this area. I'm going to go ahead and turn on the overlying workings, and don't get scared. So this would be an example of something that you would see kind of up on a hilltop. I did not really take into account the topography on this, and I just dropped it right in just to throw this in for the project, right? So this is going to be an overlying seam that is, about 400 feet or so, 400 feet, we'll say, above the active mine workings that you'll be laying out and projecting. So that's in here. I will discuss this, even more as we go along. Just like we were doing in the surface mining class, we're going to be basically sort of going through it, together as we go. But let me turn that off for now so that I can show you the more important part. And that is the underlying workings. So prior mining in the underlying seam, and you can assume that this goes on in other directions as well, out to the east or something like this. But I've only drawn it in for the area sort of interest here. And so what we're going to be doing is we're going to be designing the pillar size for the one west mains, and we are going to be laying out 4 panels to the right. 1 right, 2 right, 3 right, 4 right. So this gives us time for 4 different scenarios, right? And so we have our first panel. Because of the way I drew this on purpose, there is no underlying mining, right? So there's nothing there. The second panel has room and pillar development with, a large block size, where these pillars are 80 by 120 foot centers. This would be equivalent to like maybe mining over a set of mains or something like that, or a panel that was going to be retreat mined and they ended up not retreat mining, something like that. The next panel, just hatched in this orange color, has been fully retreat mined. There are two lever rows in the back for the bleeders. I didn't connect those in, but yeah, whatever. Like I said, this is a little bit fictitious. So this is fully retreat mined. They did take a 30-foot slab cut on the left. Half a block is remaining on the right. And then also two lever rows at the mouth of the panel as well. Right. So the following panel, I didn't hatch it in either, but it's outlined in yellow. And for this panel, number 4, or 3 in this case, but 4 for our panels, we're going to assume that these blocks have actually been split sort of in the middle. So this is like a partial pillaring. And so we'll basically just assume that these blocks have been split in half across the middle, and then we'll be mining over top of it from there. So, the thought process for this is going to be, especially when you're just starting the layout, you're just deciding, first things. This is probably the most important part, right? Checking out what's next to you, seeing what area you've got to work with, checking out what's above or below you, in this case, below us, and going from there and taking it step by step. And like I said, I'll be introducing, additional software that we'll be using for this. We'll be using ACPS to design the pillars, that sort of thing. And we'll go from there. And that's where we are right now. Make sure I've got all the layers covered. I do. We can put the other sort of mind map in there as well. And it looks, like I said, it looks kind of crazy, but we're going to work through it, and we're going to come up with sort of the best design we can, and go from there. Next time, well, I'm gonna make printouts of these as well. Both 200 and 500 scale is what I'm planning. This might be large. It's a long way back to here, but anyways. I'll try that on different scales, and if it doesn't work out on those scales, I'll get back to you. And in the meantime, I'm going to be putting together a couple little presentations, sort of just with all the details for both projects. I will show you, there are a potential reason for why, coal might be left like this, and we're going to go mine it now. And there's a number of reasons why it might have been left. It might be thin. It might have a parting. Might have bad roof. There's a number of sort of reasons why it wouldn't have been mined yet, and that is the case here. If you look at this, this is the kind of coal section that we're going to be using for this property. It's got a very thick coal parting in it, and I'll be discussing ways that you may or may not. Okay, it really just depends on the rock, but you may or may not be able to use this to your advantage, and I'll show you how to sort of determine, if you'll be able to do that or not as we go. But this is kind of what it looks like, and that's why I was left behind. There's not actually all that much coal here. There's a lot of rock, but this is common in the region. So with that, that's our plans for the project, and we'll see you next time.